Okay, this is topic for vertex form. All right, so here's your video going over vertex form. Just a reminder, this is what vertex form is. I'm ooh, excuse me. I've briefly gone over it, but this right here is vertex form. Okay, so remember this is standard form for quadratic right here, where you have ax plus bx plus c square or plus c. Now, they both will give us that U-shaped graph, right, where it's a U-shaped graph, but one of them is called vertex form because this form right here I don't even have to worry about doing any work, and I can already get my vertex. I can get that point, that x comma y, and I'll show you how later on in a minute. Just a reminder, when we had this, we had to do a few steps. Let me go back up to my notes so I can show you. Here we go, like this. Remember, when it was when it was in standard form, all right, what do we have to do? First, we had to find the axis of symmetry, right? Negative b over 2a. We plugged in that, and then we got my x value. And that's not even it, right? So then we have to take this, and you plug it into your function, and then we get my y value, right? And so therefore, then you have your vertex. Well, the form that we're doing today, it's super easy, super simple. Watch and see. Okay, so right here, we need to figure out what the transformations that occurred. So let's go ahead and list those real quick. Which transformations occurred? So just a reminder, for the transformations, we have here's one transformation, we have something happening inside of a parentheses, and then we have something happening outside of the parentheses. So right here, we have three transformations that are occurring. So just to be very quick, the very front, this is going to be when you're multiplying a number outside, this is a vertical stretch, right? It's a vertical stretch, and it's a scale factor of 3. All right, there's one. Now what happens when you subtract inside of a parentheses, you're moving the opposite of what you normally would think, so you're going to move right 1 unit. All right, and then what happens when you're adding on the outside towards the end, this is just normally what you would normally think, so this is up 6 units. Bam, so there's my transformations. That's how we filled that out. Now, how would I fill out this? Max, min, concave up, down, vertex, and line of symmetry. Right now, with this first one, I'm going to just kind of graph in the calculator so you see how we find all of that. So let's go ahead and pull up my calculator. Bam. Okay, so the first thing I would do is I would go to y equals. Y equals is right here. Hit enter. Then we're going to type this in exactly how it is. So 3 parentheses x minus 1, close that, square it, plus 6. After you have that, we hit graph. All right, so here's my graph right here. Now, based off this, I can already determine if it's a concave up, concave down, and max or min, right? So let's go ahead and write that. So I know that this has a minimum. Oops. Let me see. Dang. Sorry, guys. My stuff's messing up. Come here. All right, so get that. Now I'll bring this back over here. My bad. All right, so this has a minimum. Okay, since we know it has a minimum, and it's also a concave up. Okay, so now we need to find my vertex, and here's how you find your vertex. You hit second, and then you hit trace. Now, here's what you have to determine. Is it a minimum or a maximum? Because that's how you figure it out. So in this case, mine is a minimum, so I'm going to hit number 3. In the left bound and right bound. Now, if you guys notice on your calculator that you're using, you should have a little blinker. Mine, where is it at? I don't know where it's at right now, but let me see if I touch the screen. No. All right, so let me hit the zoom. I'm gonna hit 6 standard to bring me back. Press enter. Enter. Nope, that's not right. Zoom trig. What does that do? Zoom out. Dude, what am I doing? I'm wasting time on this video. Format. Jeez. Window. Sorry, I'm so sorry. I'm missing something. Zoom fit. There we go. Whew. All right. Zoom fit. Sorry, I messed up. Sorry. I want to record this video over, so let's keep going. All right, so this is what my graph looks like right here. Now remember, I'm trying to figure out my vertex. Sorry, I know you're confused. Remember what I did when you hit the second? you hit trace, and we said it was a minimum, so I'm gonna hit 3. Now, you see this little line right here? You should have a blinker. Yours should be blinking. Okay, so now what we need to do is we need to tell this calculator what to scan in between. So it says left bound, so I need to have this little arrow thing, this little thing that's moving up and down. I need to have that on the left side of my vertex. So I'm gonna press enter here. And then I need to move it all the way across past my vertex, because I know my vertex is somewhere right about here. I'm gonna keep going past. I'll say that's good enough. Press enter. So now it needs to scan it. Yours, you have to press enter one more time because it says guess. And now it tells me my vertex is 1,6. I have my vertex is that. My line of symmetry is whatever x value crosses. So x equals 1. Bam. My bad. I know that took a while. All right. So we're going to keep doing this. Keep moving on. So again, we need to list the transformations that have occurred here. All right, I'm not going to do all of this just for the sake of time. Let's go and list these transformations that have occurred. So we have a negative here, we have a positive 2 being multiplied, we have a plus 3, and we have a negative 9. All right, let's go and list those very quickly. When we have a negative outside your parentheses, this one right here, oops. We have a negative outside, that is a reflection, right? Reflection over x-axis, over x-axis, bam. All right, cool. What is this 2 being multiplied on the outside? That is a vertical stretch. It's a vertical stretch, right? Anything greater than 1 is a vertical stretch. Anything in between 1 and 0 is a vertical compression. So this is scale factor of 2. All right, cool. If I'm adding inside of the parentheses, it's the opposite of what I normally think. So I'm actually going to move left 3 units. And then we have move down, or shift down, move down 9 units. All right, bam. Okay, now let's just think about this real quick, whether we have a max or a min vertex in line of symmetry. Oh, actually, I didn't address something. Let me work backwards, actually, so you guys kind of see. We discovered that for this function right here, my vertex was 1,6, right? That's what we discovered. Now, the reason why it's called a vertex form is because we can get our vertex from just looking at this function, right? Just looking at this. Here's how. We look at this value here, and we look at this value here, okay? Because when it's in vertex form, we can get my x value and my y value. Now, I want you to notice, though, when you get your x value, you always take the opposite. So this was a negative 1, but it's actually a positive 1. But when we get our y value, we just bring down that 6, right? We bring down whatever's that last. So that is actually my vertex. Now, if I wanted to find my vertex here, it's the same way. Oops. So it's the same way. So I do my this, x comma y. This is my h and my k, because that's in vertex form. So then my x value, whatever goes here, is this, but the opposite. So it's actually a negative 3. And then my y value is a negative 9. So I just found my vertex, and that's why it's called vertex form, because it's that easy. So negative 3, a negative 9 is my vertex. Okay, now that I have my vertex, we can find my line of symmetry, because it's that x value crosses x equals negative 3. Bam. All right, now how do I do this without a calculator to figure out if it's a max or a min? Let's think about this real quick. This right here, what I'm pointing out, this little negative sign, what does that mean? It means it reflects over the x-axis. So let's draw a picture real quick to kind of picture this right here. If this is my graph and this is my parent function here, x squared, if I reflect it, it's going to look something like this, right? Not precisely, because it has to shift left and right, given this right here, but I'm not going to do that. I just know for a fact that it's going to be facing downwards. So if it's facing downwards, does it have a max or a min? If it's facing downwards, it's going to have a max, right? It's going to have a max. And if it's facing downwards, it's going to be concave down. You would do the same steps for this one, number 3. But I'm going to keep going on. All right. So these here, we're doing the same thing, but we need to add one more thing. We need to find the range. Okay, the range. All right, so we're going to do this without using the calculator, just so we can get the practice to it. So again, if I wanted to use, let me just write my formula, y equals what is it? A parentheses x minus h squared plus k, where h comma k is your vertex, right? H comma k. So let's go ahead and write that down. I know that my h value is going to be a -4 because I need the opposite of that. My k value is going to be a -2. So I found my vertex. Let's go ahead and write that real quick. Where's my vertex? Oh, it's right here. All right, -4, comma 2. All right, now that I know my vertex, I definitely know my line of symmetry. It's actually x equals -4. Okay, cool. And then let's think about this again. There is no negative sign in front. There's no negative sign. So I know for a fact that it's going to open up. I don't know exactly how precise I can be, but I don't know for sure it's opening up. So if it opens up, that must mean it has a minimum. So it has a min, and it also is opening up, so concave up. And then we got to figure out domain and range. Domain and range. Let's just think. Sorry. Dang, man. Getting all the stuff in this video. My bad. Excuse me. All right, domain for this right here. Remember, domain for a quadratic is always all real numbers. And then range, let's think about the range real quick. Now, here's what I recommend for you guys when you're trying to think about the range. So first what I must do is I'm going to draw my coordinate grid. Bam, 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 bam. All right. Also remember, these are my quadrants. If you don't remember these, I'll explain it briefly. Okay, so this is the first quadrant, second, third, and fourth. So it goes first, second, third, and fourth, so it goes counterclockwise. Okay, now the reason why I'm doing this is because this is going to help me find my range. So let's plot this point -4, 2. We don't have to be precise, but where would you find -4, 2? I know -4 would be going this direction, and then -2 would be going this direction. So let's just say that this vertex right here is somewhere right here. So let's call this -4, and we'll call this -2. Okay, cool. Now that I have that vertex there, do we know, is this graph opening upwards or downwards? It's opening upwards because there's no negative. So let's just say the graph looks like this. Awesome. Now let's determine the range from this. Now remember, the way I teach you to draw a range is, can I draw a line here and say this is where my graph stops? And in this case, I can't, right? It goes to positive infinity. It's going to positive infinity. Can I draw a line here and say this is where it stops? And I can, right? So it goes from -2 to positive infinity. So my y values must be somewhere in between here, right? So my y values must be greater than or equal to -2. Y values must be greater than or equal to -2. And then transformations is what we've already done, but just to keep the video short, that's the way that we do that. Let's do this again, just a little more practice. All right, so vertex form. Let's go and get my vertex. H comma, actually I can just write it over here. Why waste space? So we have this, my vertex. This goes here, but it's gonna become a positive. This goes here, stays whatever it is. All right, have my vertex, bam. Concavity is, it's a negative sign at the very front. So we know it's gonna be reflected over the x-axis. So it has to be opening down. So we'll say concave down. And then line of symmetry, it's gonna be x equals whatever your x value, your vertex, 3. Okay, if it's opening downwards, it must have a what? It must have a maximum. So there's a max. Domain is always the same. It's always all real numbers. Now we need to figure out my range. Again, I'm going to skip my transformations because we've done plenty of practice. So range, let's figure out this real quick. All right, again, I'm going to draw my little graph, my coordinate grid. Bam, 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 bam. Okay, let me just plot this point. If I'm at 3, -9, I'm going to go this way and then that way, right? So here's 3. Let's call this 3, -9. And then we know it's reflected over the x-axis, so that means it's going to be facing downwards, right? It's going to be like this. Okay? And then we know this is 3, and this is what? -9. 3 and -9. All right, cool. So let's go ahead and find my range. Do my y values have to be less than or greater than this -9? If I'm at -9 and my graph is going downwards, my y values have to be less than -9, right? So all y values less than -9, y values less than or equal to -9. Bam, that's it. All right, so let's do 2 more examples in the very bottom, and then you guys are done for this video. Again, this is vertex form, and this vertex form is basically how to find the vertex from the function they give us and the other information. Okay, so given the information below, write the equation in vertex form. Reminder, this is what vertex form looks like. Bam. Okay, so now they give us an A, so we're going to substitute that A right here. And they give us the vertex 2, which is, remember, my H, and this is my K. Definitely wrote that backwards, my bad, guys. This is actually X minus H. My bad. All right, and then here's my -9, and it goes right there. So let's go ahead and write it. This is how easy it is. So we're going to write Y equals, my A value is 3, and we have X minus 2. Oops, sorry. This is what I'm substituting it in. 2, and then squared minus 9. And that's it, right? 3 goes there, 2 goes here, becomes negative when I plug it in the formula, and then -9 on the outside. And that's substituting it in. We'll just do it one more time with this one right here. So I know I have my A value is now -2, so I should have a -2, and parentheses X. And because I'm plugging in a -4, it's going to become +4, right? Because you have a negative already there. All right, and then plus 1. And that's it. All right, well, that concludes your notes for today, guys.